Hello. Welcome to the party. So, yeah. This is Ribbit Nerding. I'm Paul, and today going to be discussing the thing, the 6551 serial daughter card for the Jenny-O for the RIBBBIT65. So, I don't know if you've been following my posts on the Ribbit Nerding page on Facebook. So, for those of you who haven't, a quick recap. So, I had been working on doing a serial console for the RIBBIT65, which is my 6502 based computer, which is based on Ben Eater's Hello World from Scratch kit/design, and I've kind of hung a bunch of additional stuff off of it, and so no disrespect to Ben Eater, certainly I appreciate all his fine work, and definitely gave me a leg up in this whole realm of stuff, but the computer as he has so far developed it with his web series is pretty simple, and I wanted to be able to do more exciting things with it. So I went down this serial console route and changed the memory map a little bit, and it's evolving. So I had done a 6551 based serial port for the RIBBIT65, and if you were here for last week's stream, you may remember this. Nope, this. So this is the RIBBIT65, a Jenny-O board that's been modified with pin sockets here. Let me see if I can get a little closer. So, instead of a W65C22 here in a regular Jenny-O, which would make these ports useful, I put these sockets in here so that I could run ribbon cable over to this absolute disaster, which has the 65C20 or 6551 here, and a crystal for the baud rate generator, or a crystal oscillator for the baud rate generator, which then the serial connection comes over here through some resistors to a ribbon cable that would go to the USB to serial adapter that I lifted from my RC 2014 mini kit. So that was the prototyping stage, and that resulted in that board. So this board has a corresponding space here for the 6522, and the idea here is that you solder pins onto the bottom here, with the pins poking up through here, soldering on this side, and the 6551 goes here, and for trying things out, prototyping, whatever kind of other crazy stuff one might be doing, the data and control signals are also exposed on these headers and nicely labeled so that you can go ahead and drive this without actually popping it onto a Jenny-O. These are the load resistors. This is a decoupling cap for the 6551. This is, where's my pokey? I had a poker. Where did it go? Is it over there? It's not over there. It's gone, man. Well, that stinks. Well, I got a screwdriver. Maybe that'll do the trick. Oh, I'll use my tweezers. Fancy pantsy tweezers. All right. So this is a plus 5 volts and ground in the event that you need to connect a logic probe or some other thing to this in order to do some diagnostic stuff. And, you know, you can also use these as test points with a logic probe or an oscope just to see what's going on. This is the spot for the crystal oscillator. This is a jumper that you can use to either supply 5 volts to the serial device that you're connecting here, or to draw 5 volts if you're doing USB, right? So USB can provide 5 volts, and depending on what the source is, a half an amp, 1 amp, 2.5 amps, and you can actually power the whole computer from that. Or in the event that you're using an RS-232 device out here, a Max 232 or something similar, you need to supply that with 5 volts. So you would jumper this jumper. And that's pretty much it. So that is the RIBBIT65 card, or the 6551 card. And as you can see here, the ground plane is fairly clean, and there are no moats or islands or anything like that. So I'm glad that turned out that way. And while we're here, here is the much discussed and never seen until now Jenny-O 1.2. So as you can see, port A and port B are properly labeled, and this is a 74 HC86 as opposed to the 06 as I had labeled it originally. And other than that, there's no circuit changes other than the ground plane issue that had come up on the previous iteration of this board has been resolved. And so what I have done is I could not resist. The boards got here early, and I just assembled them. Sorry. So this is, let's see, make a little more light, and camera 2. This is the, back that off a little bit. Okay. So this is the RIBBIT65 with the serial board. So let's fold that back. I got these little ribbon cable doodads to make some things a little easier. First of all, every time I needed to change out the EEPROM, I had to like tuck under with tweezers to try and get those. That was nightmarish. And the weight of the boards was just kind of causing them to sag this way, and so I figured, well, I should probably relieve that mechanical strain, possible failure mode, and just use ribbon cable. So I got these little, I don't know, 10-inch, 6-inch, whatever they are, ribbon cables that allow me to kind of spread things out a little bit. And so this is the 6551 daughter board on a Rev 1.2 Jenny-O. And as you can see here, I'll use my tweezers for pointing. As you can see here, this is the solder side of a set of pin headers. Let me see if I can get this off of here so that we can actually get a better look at it. All right, so I'm gonna do this. I'm just gonna disconnect this, hopefully, and disconnect that. And is that marked for ground? Yes, it is. So I'll just go ahead and do that. And we'll set this tray aside. Where did I put the other one? Oh, there it is. Okay. So, let's take a look at some exciting things here. So, if I take this apart like that, all right, so that's the Jenny-O 1.2, and as you can see, these are the pin headers, just soldered straight through. I didn't bother to put pin sockets. I didn't bother to put the pin sockets on port A and port B. I assembled this one specifically for use with the 6551, and you'll see here that I just had my tweezers. Damn it all. I can't keep track of anything. So you'll see here that the switch position 1, which is address bit 4, is turned on, and that is to coincide with the new memory map arrangement. The arrangement of the system I/O basically has the system console at position 1. So the IRQ decoder or IRQ controller is supposed to be at position 0. And yeah, so the console is supposed to be at position 1, and I set the character display to be at position 8, as I recall. So yeah, that's the Jenny-O, and this is the 6551 board. Now, you may notice that the notch on this chip is facing that way, whereas the notch for the 6522 is facing that way. Well, you know, the finger wag from board designers that I'm going to get from this, I'm willing to take that hit. This was a quick and dirty board that I threw together, and the routing was much simpler if I just spun this around. So, and the positioning of where the 6522 slot was going to be relative to where the bus connector is on the Jenny-O and all that kind of stuff, that kind of dictated positioning of the chips and stuff. So this is the oscillator. There's the 5-volt jumper. I did not put anything in for the 5 volts and ground there. I can, but I haven't had a need yet. Here's a header for the I/O, the serial, and these screen print values. This is something that I you can't see it because of the glare. This is something that I agonized over for a fair amount of time, whether to have these marked as what transmit, from which perspective the transmit and the receive and the RTS and the CTS would appear here. So I went back and forth, and I decided I would do it from the perspective of the board. So that's what I did. And so the RTS is the board's RTS. So you would connect that to the CTS on the downstream device. The RX here is the receive for this chip. The TX is the transmit for this chip. And so on. 5 volts and ground appear here. So you can hang a Max 232 off this, or whatever it is that suits your needs. And I also, as I indicated, these are the data bits 0 through 7, and these are the control signals, the reset and clock and all that other kind of stuff. And these you can connect to these, but I didn't see a need to. And if there's a future revision of this board, these things may go away. But if I take this and I put it on the Jenny-O again, and these just line up and give it a little mash, and there we go. So that is the serial console board, and let's look at this from space, shall we? Now, I had bought, let me get this hooked up first so we can actually do a demo. And these are keyed connectors, which makes for a little bit of confusion when trying to connect everything up. But that's okay. I'll just go ahead and do that. And we'll go ahead and do that, like that. Give that a little squeeze. And we should have a functioning RIBBIT65. So this is the display, the character display that came with my Ben Eater kit. Let's see if I can, yeah, I can't really get everything in shot at the same time. And have it be kind of close up. So this is the character display that came with the Ben Eater kit. It's a 16 character by 2 line display. And that's fine and everything. But what I want to do is be able to use the RIBBIT65 as almost like a standalone computer. And so I ordered one of these, and this is a 40 character by 4 line LCD character display, and it's transflective, which my understanding of that term is it permits light to pass through the liquid crystal sandwich and then bounce off the background, but you can also use it with a backlight. And this has a backlight, or so I'm told. I haven't gotten this to work yet. This uses 2 of the controllers, at least on the front end, that this uses. On the back end, you can see it's actually got 6 blob chips here on the back. And I believe that's to, like, one of the controller chips that you access through the cable or the interface, whatever, can drive 2 downstream units. And so in order to do the full 40 by 4 display, you need 4 of those controllers. So that's my understanding is that that's what these are, and then these are the 2 that you're actually talking to through the interface. So I haven't gotten this to work yet. In principle, this should plug right into this Jenny-O, and with the right code, it should be able to drive this display. But as we are now, I believe, let's see, so this is the serial. Let's plug that little baby in. I said, let's plug that little baby in. Okay, we'll plug that little baby. We'll plug that little baby in. Okay, and then we'll apply some puer. And bang reset a couple of times. And there is nothing showing up on this display. Let's confirm that. Nothing showing up on the display. Now, let's see. Can I do... Oh, you're watching me. Hi. So, let me do that. Let me do that. Okay. So, that is the console. If I bang reset, it does that, which is what it should do. Let me take a look over here and see if I can... palettes. Upstream. Camera 1. No, let's do... Camera 3. And then do that. No, let's do camera 2. There we go. Okay. And let me bump the size up on that a little bit. Size. And then we'll do... nope. Other way. Here we go. And wrong way again. Gee, Dad, you're really bad at this. Okay. So... see if we can get a little closer to the display. All right. So, what I've got is, and of course, unless you're really, really comfortable with 6502 machine language, none of this will be really compelling, I suppose. I suppose I should leave my mouse pointer there. But if I do P8000, enter, and it, yeah, I've messed up something in the monitor program so that at the end of a page read, it goes ahead and flies off into hyperspace and restarts the monitor. I need to fix that. But setting that aside for the moment, what we're looking at here is at 8,000 hex, which is the start of ROM, there is a program. And what this program is a hello world, a very straightforward hello world program. And if I go to P E-O-O-O, that is actually the beginning of the monitor program. So I've moved the monitor program into the high 8K of ROM. And the reason I did that is because I've decided to break that 32K ROM into 3 or 4 8K blocks, with the lowest block being pageable, bank switchable, and some large number of other ROMs could be hung out there. I believe up to 14, because we have to be able to reference the native core ROM, and I want to use one of those positions as the cartridge ROM. So basically what you could do is you could build this machine out. Let me go over here. Basically what you can do is build this machine out so that you have a bunch of available ROM programs, all 8K apiece, and the ability to, and have those be built into the system, and then have the additional ability to just pop a cartridge in and off you go. So that's kind of the plan there. Yeah, so I had to get the monitor out of the bottom 8K of ROM, so I moved it up to the top 8K, and the intervening two blocks are going to be for system routines, excuse me, and you know, IO routines and stuff like, excuse me, and also constants and lookup values and stuff like that. So the actual size of the monitor ROM itself is going to shrink quite a bit, because my plan is to have the monitor ROM make use of these system calls and lookup tables and stuff that are in those commonly accessible locations. And those commonly accessible locations, and none of the system, the monitor, the system routines, and the lookup tables and constants are all outside of that pageable ROM. So the pageable ROM can just be a program to do a thing, like maybe it's a DOS, or maybe it's, you know, some other kind of thing. So that's the plan there. But so currently in that low 8K of ROM is a Hello World program, which I will now hopefully demonstrate. So if I go over here and I do that, good. And I go back down here, if I say R8000, and this lighting situation is horrific, maybe that will help. So when I do enter here, it says hello RIBBIT65. Granted, the contrast is garbage and everything, and I'm just using fixed resistor for adjustment of the contrast. So I'm stuck with it for now. But ultimately, what I plan to do is have the display on a separate board that would plug into the output from the Jenny-O. Another thing that I'm planning to do, actually, let me do that so I can see what's going on. All right, so let me change this to camera 3. And we'll go over to camera 2 here. We'll do PNP. Bam. All right, so as this machine sits right now, this core board works. It's reliable. It's bigger than it needs to be. There's some superfluous stuff on here that were I to start from scratch and redesign this board, I wouldn't have done it this way, but it works. But what I do want to do is, like, don't get me wrong, I'm glad I have the Jenny-Os. They work, and they're really useful for being able to hang a new peripheral off of the RIBBIT65. So don't take what I'm about to say to be any kind of, oh, sure, Jenny-O, you made it and now you're throwing it away. I'm not throwing it away. But what I do want to do is rejigger the address decoding so that instead of having, like, here's a Jenny-O and there's 6 ICs here that are doing address decoding. Here's another Jenny-O with another 6 ICs doing address decoding. I can simplify a lot of that on one board if I can put the VIA for this and the 6551 for the serial card and all that kind of stuff consolidated onto one board. So what I'm thinking about doing is doing a board to hang off the side of the RIBBIT65 core that will do the system IO, right? So it'll do the address decoding for the system IO. It'll handle you know, there'll be a place to put the interrupt controller and all that kind of stuff. And it'll be one bus connector that goes from the RIBBIT65 core to the system I/O, and I'll have slots. They're probably going to be, you know, just these sort of pin socket slots. And I think I worked it out to, or I may do, you know, the dual row thing, like the RIBBIT65 bus, but a simplified version, because you don't need all the data lines, right? You just need, or you don't need all the address lines, sorry. You need chip selects, you need a clock, you need a reset, you need, you know, an interrupt line, you know, all those kinds of things, and you need the 7 data lines, and that's it. And so on that board, I could build out the sockets to connect to the peripherals, and have the basic peripherals that would be the character display, the serial console. I also want to do a serial keyboard connect, and I don't know if that's going to be PS2 or if it's going to be some other, you know, just straight serial or what. I don't know. I haven't worked that out. But at a minimum, on board, I want to be able to drive the display and do a serial console and a local keyboard and a couple of COM ports so that I can send, you know, transfer data in and out. And that's kind of what I think my next step is going to be. Alternately, and this is, you know, subject to consideration, and if anybody watching this video has any thoughts on this, I'm all ears. But I've also considered the idea of taking the RIBBIT65 core and just building it onto the system I/O board so that it's all there. It's just one machine. I mean, the RIBBIT65 core board is handy for whatever wacky thing you want to do. You've got, at a minimum, a 6502 with RAM and ROM and a bus. And good luck, you know. It's definitely handy as a starting point. But if I'm honest with myself and I'm trying to do a computer, well, it might be more better to have a computer on one board as opposed to ribbon cables and bus connectors and all that other kind of happiness. So jury's out, but as I work out what I'm going to do for either the System I/O board or System I/O board and RIBBIT65 core integrated, or RIBBIT65 core and System I/O integrated, I want to work out a serial keyboard, and I want to make sure that I can do RS-232. So, still stuff to do, and probably going to be using Jenny-O's for that. Not entirely sure, but yeah, that's kind of what's going on now. So, hello, RIBBIT65 works. I'm happy about that. I'm going to be working on trying to get the 40x4 character display working. So keep an eye out for that. And then, you know, design updates on the I/O board, dealy bop. Anyway, I think that's about it. If you enjoy this content, please like and subscribe. If you don't, that thumb down button works. And there will be more of this stuff coming up. If you have any questions or comments, please leave them in the comments below. Or in chat. It doesn't look like anybody's chatting right now, so we're just going to skip that part of it. And I think that's going to do it. So thank you for watching. Like and subscribe if you like the content. And that's going to do it for now. Thanks. And have have a lovely day.